Okay, welcome back. In this video, we are going to go over the same concept of finding absolute extrema in a closed interval, but we're going to do it with a function that is a bit more complicated. So my first step always is to realize that I have some endpoints here, and that they are going to be possible extrema. So I create my table. I'm going to use f of x in this case instead of y, just to make it clear where those y values are coming from. And then I'm going to put in my -1 here, and then I'm going to space out the 2 just in case I get critical points here. You may get 1, 2, 3. You just never know how many critical points you're going to get. I can already put in my -1 into the function and find that, and I can also do the 2. So let's go ahead and do that real quick. So putting in -1 is going to give us 5, and all I'm doing is plugging it in here for x. And plugging a 2 in, I'm going to need a calculator because I'm going to end up with, let's work it out here. I'm going to end up with 3 times 2 to the 2/3, which is not going to come out to a whole number, minus 2 times 2, excuse me. And so when I work this out on a calculator, I get 0.7622. And already I know that this is a lower y value than the one up here at 5. So right now this is winning. This would be not really winning, but this is my absolute min. And right now this is my absolute max. But now I got to go check on CP. So I'm going to take the derivative of this function. It's still a power rule. No, nothing crazy. So it's going to be 3 times 2/3 when I bring this power to the front. Times x, and then in the x I'm going to subtract 1, so 2/3 minus 1, or 3/3, gives us -1/3, and then that's of course minus 2. I'm going to clean this up a little bit. Looks like I put a 2 here when it should be a 3. I'm going to clean it up a little bit just to make things easier. Those 3's go away, and this becomes 2. And I'm going to bring my x down. Now it's a positive exponent, minus 2. The first thing I'm going to notice that I want to check is, can this be undefined? And the answer is yes. I mean, if you let x equal 0, you're going to clearly get an undefined situation. Now in the original function, if I put in 0, 0 to the 2/3 is 0. That's not a problem. So that means that this function is continuous. But once you take the derivative, you do get an undefined situation. So that is your first CP, x equal to 0. I'll just put my CPs over here, and then I'll list them in order here once I know all of them. So this one came from first derivative undefined, and now I'm going to go ahead and set it equal to 0 to see if I can get any CPs from there. Students always forget to check the undefined, so don't forget to check that, especially when there's rational functions involved. I'm going to add 2 to both sides. That gives me 2 over x cubed, x to the 1/3, equal to 2, or 2 over 1. I can cross multiply at this point and get 2x to the 1/3, or you can multiply by the denominator, same thing, is equal to 2. So you see where this is going. I'm going to divide by 2 so that x to the 1/3 is equal to 1. Now when I want to get rid of this 1/3, so the way that we do that is we take the cube root. You do not put plus or minus unless the index is even. Since it's odd, I just get that x equals 1. So that means I have 2 CPs to deal with. I have 0 and I have 1. The first one came from the derivative undefined. The second one came from the derivative equal to 0. So I'm just going to put those in here. And what I need to do now is check the y values for those CPs. And that is going to come from the original function. You can see here if I put a 0 and a 0 that I will get 0. And if I put a positive 1, that would give us 3 minus 2 times 1. Also 1. So now that I have my table of values, I can definitely see what the highest and lowest y values will be. My highest value, of course, is the 5. So this is going to be my absolute max. Remember, the absolute max is actually the y, but it's located at -1. So this is your absolute max. And then your absolute min looked like it might have been 0.762, but we have a lower value at 0, 0. So that is your absolute min. Just to give you a visual of this, I'm going to go over to Desmos. And here's the graph. I've graphed the graph and I have it restricted from -1 to 2. And you can definitely see here, sorry about that. That's better. You can definitely see here where that absolute max ended up being that endpoint. And I did have another endpoint here, but it wasn't quite as low as the 0. So this of course matches. You see here your critical point that showed up as a derivative equal to 0. And it is a local max, it's just not an absolute. So both of these got disqualified when looking for absolute max. We haven't really talked about finding relative min yet algebraically. We'll talk about that in a future lesson. But right now we're focused on absolutes, and clearly that would be 5 and 0. Alright, I hope this video was helpful. And I will do one more involving trig. So stay tuned for that one.